Hello, I'm going to explain what integration is. So the integration is the opposite of differentiation. So if we look at this equation, they read that the integral of 5 with respect to x. How you read that in words is what equation has a derivative that is equal to 5. You can ignore the little floofy thing and the dx for now. Just think what equation has a derivative that is equal to 5. And we also call these antiderivatives because we're looking at the opposite direction of taking a derivative. So in this case, we're starting with a rate of change and we're finding the level above that. So if we look at the integral of 5, well, 5x has a derivative of 5, so that's an answer. But so does 5x plus 100, or 5x minus 2. Those all have a derivative of 5. So they're all answers to this question. So in general, we write the answer to this as 5x plus c. And c here means any constant. We don't know if there is one. We don't know what it is. So we just put plus c. All right, so we're going to look at graphically at what's going on with this plus c situation. So I'm going to start out by drawing the graph of a line of 5x. Actually, we're going to keep with our same example. So y equals 5x looks kind of like this. And then if we put in some other variants of that, we're just changing the y-intercept in this case, since it's a line. We're looking at parallel lines. They all have the same slope because that's what the derivative is the slope, but they are situated differently on our graph. And you could draw a whole family of those, or an infinite number of them, with different plus c's on there. But this doesn't work just with lines. Even if we don't know the equation, I just drew a random curve for this second graph. So that might be one solution, but a different plus c could be like that. So all the slopes are going to be the same. The instantaneous slopes are all the same since the derivatives all have to be the same. That means the shape of it's always going to be the same, but it's going to be situated at a different height on the graph. And that's all that's happening with the plus c. It's a reasonable thing to want to know what that little floofy thing and the dx mean. And we're going to be looking at that much later, not much later, but later in the course. Right now, it's best to just get practice of working with these and realize that that just means you want to find the antiderivative. It has to do with Riemann sums, so if you really want to know right now, you can look up Riemann sums. In particular, though, I'll just give you a little bit of a clue. The floofy thing is actually a symbol that means a summation, and the dx means that you're taking the integral with respect to x. Sometimes we have multiple variables inside after the floofy thing, and we need to know which one that we're using right now. And so that's what the dx signifies in the short run. Again, you'll learn more about that when we get to Riemann sums. And I have left you with a challenge problem. I want you to figure out the answer to this question.